and today I'm going to talk about causal analysis of California biologically impaired waters. Um, so, the purpose of today's talk is really to provide a brief introduction to causal assessment and some work that we conducted last year with the state on conducting some case studies that utilize the stressor identification process that was developed by the EPA 10 or 15 years ago. So why are we doing this? And as you all are much aware, the state of California is proposed to set biological expectations to ensure the protection of aquatic life beneficial uses for perennial freshwater streams. And the current biological expectation is being set using macroinvertebrates. But when biological expectations are not attained or met, and the cause is not readily apparent or obvious, we do to determine what the cause was and do it in a way that's collaborative between the regulated and regulatory agencies to identify appropriate cause, or we think is the cause, and then remedy the situation. Method that we're talking about is broadly defined as causal assessment, and it is a method that is formal and is designed to identify the probable cause of the impairment. And it has several advantages, two of which are that it can be conducted using available information. You don't necessarily need to go out and collect new data. It can be done using the data that you have on hand. And it's a way to engage stakeholders early in the process to work to identify the cause and a solution. Environmental assessment is really a broad category, and causal assessment is just one of many terms. And so I throw this in here really to kind of point the different types of assessments that you may hear or that are commonly batted around in the assessment world. The everyday monitoring that goes on, the evaluation of the chemical, biological, and physical states of your waters is actually a monitoring assessment technique called condition assessment, and it is being done throughout the state. And to have an undesirable condition, you really know what caused that, and that's causal assessment comes into play. And assessment is the methods used to identify the cause or the source when it's not obvious. From there, go into what's called predictive assessment, which is you can forecast from the causal relationship. You can make predictions about the future. Both assessment and predictive assessment can be to form a management action, or is the resolution to the problem. And then outcome assessment is essentially monitor for your management action to determine if you are having an effective recovery of the system, and hopefully that's the case. If your outcome assessment is not being met, then actually you can go back to doing more condition assessment monitoring and go through the process again. But today we're going to just be focusing on this causal assessment. We're going to be moving from assessment in situations when the condition is undesirable. How do you determine what that cause is? So we'll establish causation. This is a very old figure taken from the EPA TMDL program that lists the number of impaired waters and their potential causes. And you'll note down here that when, in some cases, you have actually 2,066, or about 4.5% of the cases, you have an unknown cause, meaning we couldn't attribute their nutrients, oxygen depletion, sediments, or pathogens. And this is the case that we're talking about here, when you know really what's going on or what the cause was. That's where causal assessment comes in. So in order to know, you have to know what to fix. And biological assessments are commonly used to identify impairments in streams, and in many cases, the causes are unknown. And again, why establish causation? Because we're all human, and we make mistakes about causality. And we do this in many different ways. We overweigh chance events. Give us a statement, every time I wash my car, it rains. It's not really true, but we often overweigh the chance event. Biases. All pollution is caused by industry. We're emotionally predisposed. If you study a discipline, you tend to think only in terms of that discipline. Biologists think about hydrology. Ecologists think about ecology. Thinks about chemistry. We have intuition, meaning we have a hunch. We rely on our experiences. Well, flood caused the impairment last time, therefore the flood must have caused it this time. We're human, and we tend to form conclusions quickly, and because we're smart, we can easily defend them. But this isn't necessarily how the world works. So, in causation, there's a couple things that really set it apart. Causation is really one of the most difficult and controversial concepts in philosophy. Its history goes back a long, long, long time. And you're familiar with the CADDIS website, and there'll be a link to it later on. It's a really interesting section. There's a really interesting section on the history of causation and how all these different people played a role in it. If you're in the history of science, I suggest going there. It's a really fascinating read. But a bit early, you might want to go and read that as well, because it might put you to sleep. The only way to establish causation really is using a randomized replicate controlled experiment. The problem is environmental monitoring designs are rarely randomized, they're rarely replicated, and they're rarely controlled. So just don't meet these normal assumptions for doing standard statistical tests in environmental monitoring, and we'll be able to do that. So to establish causation, we really need to rely on a formal method. We need to provide a method that's defensible and reproducible. We need to be able to identify causal relationships that are not immediately apparent. And what we're meaning or suggesting is that you need a method to kind of get past all those biases and all those traps that I presented a few slides ago. Biases and other lapses of logic. It's like an airplane. You need to have a scorecard laid out in front of you, or a chart that outlines what steps you need to follow so that you make sure every time you're checking off the right box, so that you don't accidentally miss a step and have some bad consequences that happen. And the idea behind the formal method is that you're going to increase your confidence that the remedial or restoration efforts that you're going to be actually going to improve the biological condition. There's quote down where science is a way of trying not to fool yourself. The first principle is that you must not fool yourself. You are the easiest person to fool. So to do with this formal method is to kind of take as much of the human out of the experience as possible. Establishing causation is that we talk in specifics rather than in general statements. We avoid general terms of statements such as does C cause E? For example, does smoking cause lung cancer? Or does increased water temperature reduce bull trout abundances in rivers? Rather, we focus on making specific statements. Did C cause E? And we want to know, we phrase things as, did smoking cause lung cancer in Ronald Fisher? Increased water temperature reduced bull trout abundances in my stream. Again, you just really want to be specific here and not general. And so the assessment approach that PA developed over the last 10 to 15 years has been outlined in the stressor identification guidance document that was published, I believe, around 2000. It is pragmatic, and the analysis guides actions. You're reading on the information that you have on hand and you to guide decisions. centered on abductive inference, where the best hypothesis is identified to explain the available information, rather than proving a hypothesis correct or incorrect. The big difference here is that rather than walking in and saying that we think nutrients cause this impairment, walk in saying, I don't know what caused the impairment, so I'm going to look at everything and rule out differences where I can, and I'm going to isolate those that there may be. Aim to establish specific causation rather than the general causation. That's the previous. Did X cause Y rather than can X cause Y? And at the end, likely cause is established by causal inference and the interpretation of available information. Compare alternative candidate causes. We logically eliminate when possible. We do when possible. You use a strength of evidence for the remaining ones to identify the most likely cause. Causal assessment has a downside. What's good? Well, first of all, it's a formal method, and it provides scientifically defensible results when the stressor is not readily apparent or obvious. The evaluation is reproducible. It is, for the most part approach, and everybody can do it, and you can go back in and you can analyze the data the same way that everybody else has. You actually provises and other logic steps or logic lapses. You can identify causal relationships that you didn't know were around. It engages stakeholders and decision makers early in the process, thereby reducing controversies, and it increases confidence in the selected management option. Well, they're not easy and straightforward. That you're conducting a causal assessment is you don't know what caused it. And in some cases, you can have multiple factors leading to that impairment that really make things complicated. The mechanisms of biological impacts can be complex, and this is just a straight, aspect of biology that a lot of times competitive interactions, chemical interactions, are just really much more complex and not straightforward as we would hope. There is no size-fits-all methodology. While our approach or stressor identification guidance is one size, the application to your situation could be very different than to somebody else's. The types of data that are available, the problem at hand, the number of stressors, the complexity of the systems, all drive how you do the analysis, and so there's not a one-size-fits-all method. Data. This is quantity and quality matter when it comes to doing a causal assessment. You have the better quality you have, the more likely you're going to be able to determine what caused your biological impairment. That you could go through this entire process and at the end of the day, not a smoking fish as to what caused the biological impairment. It's not that you've identified, you may be disappointed because you haven't isolated that one stressor that caused it, but alternative may be that you may have started with a list of 10 stressors and reduced that down to 4 or 3 stressors to look at in greater detail later. This is our CADDIS framework. The yellow is our stressor identification. It's the steps that are contained within the EP causal assessment approach. It begins the detection of a suspected biological impairment. With stress identification, you begin by defining the case. You then to listing candidate causes, evaluating data from the case, evaluating data from elsewhere, and identifying the probable cause. And we'll walk through examples of each one of these steps so you can see what is actually meant when you're moving through the box. once this entire process, you hopefully at the end can identify and apportion sources to develop a map action that ultimates to your resource protected biological condition. At each process, decision makers and stakeholders are engaged, and the ability to kind of go back as data acquired or more information is needed. You can always go back through the process. So it's not meant to be a one-time through when you're done. It's meant to be interactive depending upon what you learn about the course of the assessment. This information, I hope you've had time to kind of go and look at the CADDIS website. If you haven't, it's at www.epa.gov/CADDIS, CADDIS, and it's short for the Causal Analysis Diagnosis Decision Information System. There is a wealth of information on this website. Everything from moving through the stressor identification, which is in the first volume, to identifying sources, stressors, and responses, what we know from a biological, chemical, physical, stressor response models, everything we know about how biology, chemistry, and physics influences invertebrates and other organisms can be found here. There's a volume providing examples and applications. There's a volume on data analysis. We provide a lot of useful statistical tools and statistical approaches and things that people might not have in their toolbox. You go here and get access to a lot of different ways to analyze data in different ways and different fashions. This really isn't Statistics 101. And we do Causal Database, which is a place where we're continually adding literature and different tools on how to do causal assessment. So not quite one-stop shopping for doing causal assessment, but it's pretty close to that. And somewhere on here, under basic information, somewhere right on the bottom down here would be, here it is up here, sorry, the assessment background. That's where you would go if you wanted to get a history on how people think about establishing causation. That's the chat I was talking about earlier today. So California, a little over a year and a half ago, and we were contacted by the state to kind of help them or to explore a method that when biological objectives weren't met in streams, was there something that could be done to help the regulated and the regulated communities identify what the stress situation was and in a collaborative way. And it comes out that the early recognition that not every stream is going to meet its biological objectives. So when you're not compliant, an attempt to determine what the cause was in order to hopefully establish the appropriate remediation method. And assessment approaches have not been well vetted in California. They've been used pretty much on the East Coast and in some other places. The diversity and uniqueness of some of the California streams, it was really thought that the best thing to do was to come out and conduct several case studies and actually evaluate or assess causal assessment for California. And that's where the idea behind conducting 4 case studies to apply method, see where it would be useful, what fell short, what worked, what didn't work. And at the time was to begin the process of training people from the regulatory agencies and the regulated entities on how causal assessments could be done. So it was kind of a two-way street. There was a learning curve to teach people, training session, and then we were getting feedback on the actual method itself and where it could be improved and where it wasn't working. We've done 4 rivers, the Salinas River in Central California, which was an agricultural dominated wetland or stream. The Garcia River is in Northern California, which was dominated where you had lots of timber harvesting going on, and then the Santa Clara and San Diego rivers, which are both examples of urban streams. So to go through the process, we had to detect or suspect a biological impairment, and that can come in many different forms. It could come in kills, organismal anomalies, changes in community structures, biotic index values, or violations in biocriteria. In the case of California examples, we're using the old IBI scores to establish or to tick off the impairment. That's going to be our trigger that worked that way. This is from the Salinas River. We have an impairment detection where we have two sites at the on the lower reaches of the river, the 309 Dave and the 309 SSP, where we had a Southern California IBI index of 1419 compared to stream or to sites higher up that higher IBI scores. So these low IBI scores here were the trigger that prompted a causal assessment. So the first step in differential identification is to define the case. And this is, you have to be very specific, and you get in and you really think hard about your situation. What could be the potential causes? What could be the potential sources? What is it that I'm exactly looking at? We're looking at it. How far does it extend? What time frame am I looking at? You need to narrow down and be very specific about what you're looking at in terms of defining the case. Really important when you're stakeholder engagement, because you're defining expectations for all the groups present. You're not going, we're not considering an impairment that occurred 20 years ago. We're not considering an impairment that occurred in another watershed. Everybody's going to be focused in on the same thing at the time. And so really meant to fit everybody to a single point in time. And then finding what the biological effects are observed, where and when did they occur, and there are comparable comparative sites. And we'll get into this concept of comparative sites before, but this is really, these are sites that you're going to contrast what you see at your paired site somewhere else. You need something to contrast it to. And there was a lot of discussion on this when we did our case studies over the last year. Turned out to be a pretty big problem in California. Not unsolvable, but it was an issue. A lot, and when you're defining the case, it's really going in and understanding your system, and so it's generating a map, understanding what designated uses are occurring within the within your shed. What's its precipitation, its discharge. So you're really in this very early stages of fact gathering. What started this whole process was your IBI score, but an IBI score is just one number, and that number is actually made up of a bunch of different metrics. And so when defining the case, you begin to break the metrics down into their components, and you begin to drill down into the biological data that you have to really handle on what is it of that system that is different, or what organism is really responding or is affected by stressor. So you don't focus in on the IBI score. You break down into its components, and then you continue to break down all the way to potentially the species composition level. On the second step is, again, where you're really engaged with stakeholders, and everybody's sitting around the table or sitting on a conference call or firing emails back and forth on what they think could have caused the impairment. This is really kind of thinking, I like to think about it in two ways. One is this is the brainstorming session. Everything gets put on the table. Everybody, any idea or anything that somebody thought about, somebody saw, is come to the table and put it on there. Nothing is taken off because someone does true. Everything ends up being on the list. The other thing with stressor, the way that the stressor identification is it's analogous to basically being in a court of law, and you're trying to solve a crime. And so the fun of the case is really what happened. My house robbed. Instead, it's really where the detectives come into the play, and they're looking at, okay, who are my suspects, who was around, what happened, and so you're just basically in a gathering information stage and trying to figure out who could have done it. And so when you're listing the candidate causes, doing things like making a map, you're getting information on potential sources, stressors, and exposures. You're developing a conceptual diagram. You're engaging stakeholders. The engagement with stakeholders here is really should be at a very high level, and you're working to narrow down to get a very final list, or to a list that you consider to be final that you can easily work through. A lot of this is just done through open communication. So, River, the candidate causes identified by our stakeholder groups, which consists in this case of the agricultural co-op and the regional water board. This is, I think, about 7 people identified that the likely cause for the biological impairment in the lower reaches is due to increased sediments, increased strength, increased pesticides, decomposed oxygen, increased nutriment and toxicity, fluorations, and physical habitat alterations. So pretty much all the major players one would expect to see in a when you have bad biology. You spend a lot of time. We really encourage this in the process of developing a conceptual diagram. Actually, look at these and say, "Oh my, that's just really confusing. I don't know what's going on. It's a bunch of boxes and it's a bunch of arrows." But when you systematically go through it and you work to actually look at starting from a source or a human activity and ending up with your biological impairment, what conceptual diagrams are really meant to do is capture what we call a causal pathway, or how do you get channel sediment really through biological terms and ecological interactions to biologically impaired invertebrate assemblage. And so if you look at channel sediment up here is the human activity, and channel sediment increases the mobilization of bank and channel sediment, which increases the sediment in the stream, which increases deposited embedded sediments, which decreases in interstitial spaces, which increases or decreases interstitial habitat flow, which could lead to a biological impairment. So it's setting up the chain of events that you get from biological impairment to human activity and the source that started it. So it's really just thinking about how could this have happened given all the stressors that I have. Nice when you work with it, and I recognize that some of you probably are trying to understand this in detail, and the important thing is don't at this stage. It really takes some time to walk through this, develop it, and think about it. And that's a very important process, and to talk about it with your stakeholders and talk about how people interpret what could be going on. It's meant to stimulate dialogue, and it's also meant to capture what type of data you're going to need in order to identify or to solidify increased sediment as a potential caused your biological impact. So it's multiple stages, and it's really, again, one of these things that you have to work together on this, you have to talk about it, and have to communicate, because it provides a mechanism for focused conversation and getting everybody to focus on the same thing and on a course of action. The third step is to actually begin the process for building evidence that's either going to support or not support the list of candidate causes that you developed in the second step. And so we're not going to go into this in great detail, but what you're doing is you're collecting different evidence type. And so here are the different types of evidence that you may have available to you when you're evaluating data from the case. And so you're not going to open all this information. Rarely are you going to have all data to use all this evidence type, but the one we're most interested in is what's called co-occurrence. This is looking at evidence that occurs in space and time. And it's really looking at the question of, did I have chemical data or the stressor data present at the same time that I observed my biological effect? Think of this as being a court of law and the breaking and the robbery example. This is a list of suspects where you ask the question as, was Jane present at the time of the robbery? In the same space at the same time. And it's really strong evidence if you show that Jane wasn't there at the same time or in the same place when the robbery happened. You can eliminate her from the list of suspects. So think of the evidence from the case. Again, use whatever example you can, drawing from kind of the I always find quite useful to kind of help through this. But we have all these different types of evidence. They're in great detail on the web page. And go through all of them would probably take the better part of 2 days. Which when we did sessions, our training sessions were slated to occur. I think we were out in California almost 3 weeks to people on how to do this. One of our causal pathways, and in this case, what you have really relying upon work through the conceptual diagram that was generated in step 2, deal with data that supports the odds that I would expect to see if suspended sediments were having the biological effect. And so in this case, if suspended sediments are having an effect, you would expect there to be watershed land cover alteration. And so as data showed our impaired sites, the 2 sites, David's and Spreckles, versus our comparator sites, that we had more developed land than these sites. We also had a tendency to have more cultivated crops. If land cover, we would expect there to be an increase in watershed erosion. So what evidence do I have available, or what data do I have available that would only support this concept of increased watershed erosion? And so I have great cumulative rainfall occurring in my impaired sites than in my comparator sites. I have more, somewhat even groundwater withdrawals. Have a bunch of irrigation methods that are being applied to those areas as well. And for the next box is, if I increase watershed erosion, I would expect to see sediment delivery, an increase in the amount of sediments delivered to a stream. And so, did you see an increase or data somewhere available that actually make that assumption or find out that, yeah, indeed, the tributaries flowing into the main stem of the Salinas River have a higher turbidity and therefore could be a source. And because evidence that points towards each one of these boxes, we would score this as a plus, meaning that we actually have some information to support this causal pathway. And so we continue to investigate this. It's not definitive proof, it's just one piece of evidence evidence support a conclusion. Evidence is a very different type of approach. Really focuses in on your site, your water, your river, your watershed. 4 is where you begin to bring data from other places into the site to kind of lend the support or to help support or refute some of the conclusion draw during step 3 when you're evaluating data from your case. Here, relying on laboratory studies, field studies, or ecosystem models that are conducted somewhere else. You can think about pesticide invertebrate responses to pesticides. The response relationships are derived from laboratory studies, but you can use that information to help support whether or not pesticides were having an effect in your stream. Different types of evidence that you may use are mechanistically plausible causes, manipulations at other sites, or verified predictions, stressors. In the log example that I was kind of referring back to, this would be bringing in an outside expert, a witness testimony from somewhere else to kind of help support what you saw at your crime scene. All this comes together to provide what we call a weight strength of evidence. In cases you can eliminate, in other cases you can diagnose. This is really done by comparing strength of evidence across different causes. This big ugly table is the net result, where you sit up the top here are the different essential stressors that the stakeholder can be identified as causing the impairment in the lower Salinas at site 309 Davis. And when we compare it to a comparator site, our 309 SAC site, down here are the different types of evidence that we had data for, and then how we scored it. So if you saw anything in meant that the data did not support that type or that stressor as being the cause. So here for temporal co-occurrence and decreased dissolved oxygen, it was scored a negative and a red, meaning that it was unlikely, given the data we had, that DO could biological impairment. Whereas to build up what you see here and increase sediments, where you have a bunch of different data, a bunch of different evidence types that all are pointing in the same direction. So note that these are all pluses, and believe they're in blue. I'm being colorblind, so give me if it's green. And they're all down here. This is strong evidence. We have a lot of data, a lot of support from a lot of different evidence types that this likely cause a biological impairment at site 309 Davis. Some cases where you have mixes and matches. Really up to stakeholders to discuss, how to interpret and what to make of a match of scores. But in this, it worked out pretty well where we had a form decision. At the end, what you look at all your stressors, and you basically classify it as to those that are likely. In the case of Venus, we identified suspended sediments, and here was the evidence and the comments that we provided to support our conclusions. Physical habitat was also a potential factor, but mainly because of the effects of suspended sediments. We were able to determine unlikely contributors, dissolved oxygen, nutrients, ionic strength, and flow regime based data that we had. And so again, this just kind of provides an example of how we reached that conclusion, or what we're stating as our conclusions. But find in this, which is things that we weren't able to resolve. Pesticides and metals in the lower Salinas, we weren't able to say whether that was or was not a potential cause because of the very limited data we had available for us. So it really kind of says, it provides a really good point for stakeholders to talk about how is it that if people feel pesticides are a potential contributor, how to better design and collect data to allow it actually associate the impairment we saw on that particular day, on that particular stream reach, as being caused by pesticides. This information together, hopefully stakeholders and the regulatory agents can get together. They know what the potential cause is. They've narrowed it down to suspended sediments. They know it's not a nutrient issue. They know it's not a DO issue. So let's focus our management strategy on dealing with suspended sediments. The conversation on that, let's put our resources to that, and then hopefully develop a management action plan that will resolve the problem and bring the biotic condition back up. So causal assessment, in conclusion, is a one step in the environmental assessment. Its sole purpose is to identify a cause. That's it. It's not condition assessment. It's not the monitoring that goes into establishing causation. It's not the monitoring step that determines this of your management action. Its sole purpose is to identify and narrow down what the likely cause of the biological impairment is. So to remember is it's very specific. We focus on did X cause Y, not can X cause Y. It's based on data that you have available to you, centered on the 5 steps of the stressor identification process. So this, again, just that where it falls within the whole process. It's iterative. It's a continual process. Causation's relatively new in the field of environmental sciences. You don't see it bounced around a lot, but it's a very powerful and informative tool given the types of environmental data that are currently collected by a lot of people. From the whole process says that formal process which encouraged stakeholder involvement, fostered and focused communication. There's a lot of great discussions around the table from the stakeholders, just kind of laying out what they're going on and developing the models. And look, I think we got on the method was just on how well the method encourages communication and the types of communication outcomes that result. In any candidate causes, when you had pretty clear data that suggested that couldn't be the cause, it was a real method. It's really good at reducing or weaning down the numbers. Where it kind of short is when you have, when you have 3 or 4 candidate causes remaining and you don't have the data for it. Getting down to single cause or single stressor is really, really difficult. What came out recommendations for the existing condition assessment monitoring program to increase causal assessment effectiveness. Really the types of monitoring programs that are in place now that were to assess environmental condition don't necessarily make for effective causal assessment monitoring data sets. With a little tweaking and a little movement around, and once people become familiar with what's required by causal assessment, the 2 monitoring programs can be strengthened to maximize information gain. Recommendation for California is that there's a lot of different types of data that can be used to develop specific tools for California. It's just going to take some time and some effort to put those together. The formalized comparator site selection is the largest, and the comparator site, notice we call it a reference site. Reference sites are typically those very clean, high-quality sites that everybody wants to get to. When you're doing causal assessment, the comparator site can't. The reference site isn't always the best example because it's clean for a reason. It's low in nutrients. It's low. It's not exposed to pesticides. Has good high quality water quality. It's got good habitat. It's got good flow. But when comparator site that's really messed up, you're always going to find it's going to be really hard to narrow down what the cause of that was. And comparator site selection is more focused in on local sites or sites that are within a close proximity to your impairment or the site you're defining as your case. And the problem in California was that basically all sites were always bad. Some contrasts, you can always use a bad site as a comparator site, but the bads were always similarly bad. So we weren't able to really get a good contrast to really identify a cause. And techniques and some methods and utilizing the state's databases that we're hoping to develop some guidance to refine or to provide a guidance as to how to go about selecting a comparator site, going from what would be a good comparator site all the way to have the sites around us. So what do we do? So with these are the acknowledgments. We partnered with Ken Schiff and Dave Gillette from SERP, Pete, Jim Harrington, and Andrew Reed from the Department of Fish and Game. Our stakeholders group, there were 16 in total, representing the three case studies. We had the regional water boards, the autonomous municipalities and section districts and different co-op groups that were all participated in it. And then Mike Paul from Tetra and his team from Tetra Tech helped establish this. So I will end it, and I would be happy to take questions.
It's time. You can send your questions via chat, or you can unmute your phone by pressing *6 and ask out your question.
Hello?
Hello?
Yes. Can I ask my question? Sorry.
Yes.
Yeah, I'm in California, and as mentioned, I'm sorry, can you hear me?
Yeah.
Okay. I'm in California, and as you mentioned, it's very difficult to find the comparative sites, and it's also very, very difficult to find reference sites unless someone goes in somewhere in mountains where there's no human activity or so. So I was wondering if one wants to start that, they can just go through this method that you explained and don't focus so much on a comparative side. They can still get some causes.
The you use, if you look at comparator site, can you just go to a site and use the data that you have available to eliminate or identify stressors?
Right.
But the weight of evidence becomes, if you don't comparator site, the advantage of a comparator site is that it provides you the contrast. And so our ideal world of a comparator site is a site that is very similar to your impaired site, but differs in one or two stressor attributes. And so your or a site that maybe has a slightly better biology or a different biological community. So you think about a site that has an IBI score, let's say, for example, of 14, and I go upstream and I have a site that has a score of 14, but when I look at it, the bugs actually make up those sites, I find that they're two very different communities. I use that contrast to base for evidence. And you're right saying that the reference sites usually don't make very good comparator sites because the bug community is always going to be different, and all my stressors are going to be different. Concentrations are going to be different, space and time. That's very powerful evidence. But when you move to, I don't have any comparator site, and I lose that contrast, the strength of my argument. I lose strength of my evidence. Can do it, but it's like saying you're relying on, to go back to the analogy of a court of law, you're being your opinion that Jane is guilty of the robbery because the mailman driving by at 6 o'clock at night happened to see somebody, it's like basing it on eyewitness testimony on a very dark night that was raining. It's just not very strong evidence.
Right.
So I think you would have trouble making a convincing argument, but you do with what you have.
Okay. Thank you. Thank you.
We have at least one more question. You can send it via the chat. Just type your question in the box there, and you can select who you want to send it to. Or mute using *6 and ask your question of Scott. Scott, I have a question I'm going to read to you. What information or data sources are used to form the candidate stressor list, and by comparison between the target site and comparator site?
Can you one more time?
To copy this and send it to you. Okay, it'll appear in your chat box. It might be easier.
Two different things in there.
All right. So you should have it.
Yep. Candidate stressor list really derived data sources or from comparisons between the target site and the comparator site. The candidate stressor list is really sit down and where people think about what could the potential stressors be and the sources. You're really discussing bringing in local knowledge, different data sets, personal observations, whatever you have on hand to say, what's going on here. It may be, the kind of really bizarre example would be everybody sitting around the table and biological impairment, and everyone's looking at their water quality data, their monthly monitoring programs, USGS flow stages, and at the end of the day, somebody goes, well, you do realize that they, just a whole bunch of wetland up the road and they did without a permit, and could have been the cause. That could have been the source. So it's bringing in your routine stuff plus personal experience.